Alright, so now we have to find the max and min on an unbounded region. So what we've already done is graph the lines, find the shaded point. We've also found that sort of difficult point to find in the for the vertex. So you take your vertices and you plug them into the fxy function. That's the optimization function. Typically when we apply this, we're going to want to optimize some profit function, we'd want a max, or a cost function, we'd want a min, but we're looking for some best value. So what we do is we just plug those into the equation. So be careful of your negative signs. So negative 2 is going to give you a 2. 2 times 0 is 2. Plugging the other in, we get 6.8. So is that our maximum or minimum? Well, we don't actually know whether it's our maximum or minimum because this is an unbounded region. So we have to consider what's going to happen at really extreme values. So you can see that if we tend away from where our graph is, just more down in this region here, we're going to get more and more extreme values, gigantic numbers. So what happens then? Well, we have to consider the optimization function. It's all about the optimization function. Alright, that is definitely the key here. Okay, it is not about the shape of the graph. So it doesn't matter whether your graph points down or points up or any of that stuff. It's all about the optimization function. So let's explore that a little bit. So there's all our work. What happens when we get really, really extreme values? Well, the really extreme values for the x are going to be positive, right? Because we're going further and further that way as we go into crazy zones of our shaded region. And then the y values, we're going to go down, 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 down. So they're going to get gigantic negative numbers. So we're talking about things like 1 billion for x and negative 1 billion for y. Only numbers way bigger than that. So what happens when we plug those into our optimization function? Well, we should consider, why don't we just call it positive infinity for x and negative infinity for y? Those are the biggest numbers I can think of. So I plug in positive infinity and negative infinity for x and just sort of calculate out the algebra. Negative times anything is a negative, so that's negative infinity. And then we're going to have 3 times negative infinity, which is going to be another negative infinity. Add those together, we get a negative infinity. So we plug in the values, the extreme values, and we get negative infinity. What does this mean? That means for our optimization function, for the fxy function, when we plug in extreme values in our region, they tend towards negative infinity. So negative infinity is our least most number, so it's our minimum. So the minimum for this is going to be negative infinity. Some books would say there just is no minimum. We're going to say that minimum is negative infinity. Just depends on which teacher you talk to. So the max is going to be the bigger of these two numbers. So our maximum in this case is 6.8. All right, all done for this problem.